covering underground feeder and branch circuit cable, or off-B or non-metallic sheath cable, or NMC, with mortar during masonry construction is not acceptable due to several reasons. Firstly, there is electrical code violation. The National Electrical Code, or NEC, requires that UFB cable be protected from physical damage. Covering it with mortar can damage the cable and its insulation, leading to potential electrical hazards. Secondly, there is moisture penetration. Mortar is porous and can absorb moisture. This moisture can penetrate the cable, causing it to become damp and leading to electrical problems such as short circuits or ground faults. Thirdly, there is corrosion. The chemicals in mortar can corrode the copper conductors in the cable over time. This corrosion can degrade the cable's performance and eventually lead to failure. Fourthly, it creates difficulty in troubleshooting. If a problem occurs with the cable, it can be difficult to locate and repair if it is covered in mortar. This can result in costly and time-consuming repairs. For proper installation, UFB cable should be installed in accordance with the manufacturer's instructions and the NEC. This typically involves several key steps. 1. Laying the cable on the surface of the masonry or in raceways or conduit. This provides physical protection for the cable and prevents it from coming into direct contact with the mortar. 2. Securing the cable with cable staples or ties. This ensures that the cable is properly supported and does not sag or become damaged. 3. Protecting the cable with fire-stopping material where it passes through fire-rated walls or ceilings. This helps to prevent the spread of fire in the event of an electrical fault. If your UFB cable has already been installed covered in mortar, it is recommended to have it inspected by a qualified electrician and replaced if necessary. This will help to ensure the safety and reliability of the electrical system. The NEC provides detailed guidelines for the installation of UFB cable. Some key considerations include using the correct size of cable for the intended load, ensuring proper grounding, and protecting the cable from physical damage. Article 334 of the NEC covers non-metallic sheath cable, including NMC and UFB. It outlines the permitted uses, installation requirements, and ampacity ratings for these types of cables. UFB cable is designed for underground use, including direct burial in the earth. However, it is still important to protect it from physical damage and moisture. When installing UFB cable in masonry, it is best to run it in a conduit or raceway. This will provide additional protection and make it easier to replace the cable if necessary. If running UFB cable through a wall, use a conduit or sleeve to protect it from abrasion and physical damage. Ensure that the conduit or sleeve is properly sealed to prevent moisture from entering. When securing UFB cable, use cable staples or ties that are specifically designed for this purpose. Do not use nails or screws, as these can damage the cable insulation. When installing UFB cable in a damp or wet location, use a moisture-resistant sealant to protect the connections. Inspect UFB cable regularly for signs of damage or deterioration. If any problems are found, have the cable repaired or replaced by a qualified electrician. Always disconnect power before working on any electrical wiring. Follow all safety precautions and wear appropriate personal protective equipment. If you are not comfortable working with electricity, hire a qualified electrician to do the job. Understanding the properties of mortar is also important. Mortar is a mixture of cement, lime, sand, and water. It is used to bind masonry units together and to fill the gaps between them. Mortar is porous and can absorb moisture. It can also contain chemicals that can corrode metal. There are different types of mortar available, each with different properties. Choose a mortar that is appropriate for the specific application. When working with mortar, wear gloves and eye protection. Avoid getting mortar on your skin or in your eyes. If mortar gets on your skin, wash it off immediately with soap and water. If mortar gets in your eyes, flush them with water for 15 minutes and seek medical attention. Dispose of mortar waste properly. Do not dump it down the drain or into the environment. In addition to the NEC, local building codes may also have requirements for the installation of UFB cable. Be sure to check with the local building department to ensure that you are complying with all applicable codes. Consider using ground fault circuit interrupters, or GFCIs, to protect circuits that supply power to outdoor outlets or equipment. GFCIs can help to prevent electrical shock in wet or damp locations. Use weatherproof enclosures for all outdoor electrical connections. This will help to protect the connections from moisture and corrosion. Regularly inspect outdoor electrical outlets and equipment for signs of damage or deterioration. If any problems are found, have them repaired or replaced by a qualified electrician. Install surge protectors to protect electronic equipment from power surges. Power surges can damage or destroy sensitive electronic equipment. Keep trees and shrubs trimmed away from power lines. Trees and shrubs that come into contact with power lines can create a safety hazard. Be aware of the location of underground utilities before digging. Contact the local utility companies to have them mark the location of underground utilities before you dig. Never touch a downed power line. Call the local utility company to report downed power lines. Be careful when using ladders near power lines. Keep ladders at least 10 feet away from power lines. If you are working on an electrical project, consider hiring a qualified electrical inspector to inspect your work. An electrical inspector can help to ensure that your work is safe and complies with all applicable codes. Furthermore, consider the long-term maintenance of electrical systems. Regular inspections and maintenance can help to prevent electrical problems and ensure the safety of your home. Replace worn or damaged electrical components promptly. Do not wait until a problem occurs to take action. Keep electrical panels and equipment clean and free of debris. This will help to prevent overheating and other problems. Hire a qualified electrician to perform electrical repairs and upgrades. Do not attempt to do electrical work yourself unless you are properly trained and qualified. Document all electrical work that is performed on your home. This will help to keep track of the electrical system and make it easier to troubleshoot problems in the future. Consider using energy-efficient lighting and appliances. Energy-efficient products can save you money on your electricity bill and reduce your environmental impact. Educate yourself and your family about electrical safety. This will help to prevent electrical accidents and injuries. By following these guidelines, it's possible to ensure the safe and reliable installation of USB cable in masonry construction. Remember that electrical work can be dangerous, so it is always best to consult with a qualified electrician if you have any questions or concerns. The NEC also addresses the proper support and securing of cables. Cables must be supported in such a way that they are not subject to physical damage. This can be achieved by using cable staples, cable ties, or other approved methods. The spacing of cable supports must be in accordance with the NEC requirements. Typically, cables must be supported at intervals of not more than 4.5 feet and within 12 inches of boxes, cabinets, or fittings. When running cables through bored holes in wood framing members, the holes must be drilled so that the edge of the hole is not less than 1.25 inches from the nearest edge of the wood member. This helps to prevent nails or screws from being driven into the cable. When running cables parallel to framing members, the cables must be at least 1.25 inches from the nearest edge of the framing member. This helps to protect the cables from physical damage. In addition to physical protection, cables must also be protected from overcurrent. Overcurrent protection is provided by circuit breakers or fuses. The size of the circuit breaker or fuse must be appropriate for the ampacity of the cable. The ampacity of a cable is the maximum amount of current that the cable can safely carry. The ampacity of a cable is determined by its size, insulation type, and temperature rating. The NEC provides tables that list the ampacity of different types of cables. When selecting a circuit breaker or fuse, it is important to choose one that is sized to protect the cable from overcurrent. If the circuit breaker or fuse is too large, it may not trip in the event of an overcurrent, which could damage the cable or start a fire. In addition to overcurrent protection, cables must also be properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to prevent electrical shock. The grounding system must be properly installed and maintained in order to be effective. The NEC provides detailed requirements for grounding electrical systems. These requirements cover the size and type of grounding conductors, the methods of connecting grounding conductors, and the location of grounding electrodes. It's important to understand the NEC requirements for grounding and to ensure that the grounding system is properly installed and maintained. Also, it's good to consider the proper use of electrical boxes and enclosures. The electrical boxes and enclosures are used to protect electrical connections and devices from physical damage and the environment. Electrical boxes and enclosures must be properly sized for the number of conductors and devices that they contain. They must also be made of a material that is suitable for the environment in which they are installed. For example, electrical boxes and enclosures that are installed in damp or wet locations must be made of a corrosion-resistant material. The NEC provides detailed requirements for the installation of electrical boxes and enclosures. These requirements cover the size, type, and location of electrical boxes and enclosures. It's important to understand the NEC requirements for electrical boxes and enclosures and to ensure that they are properly installed. There are different types of cables that are available for different applications. It's important to choose the right type of cable for the job. Some common types of cables include non-metallic sheath cable, or NM cable, underground feeder and branch circuit cable, or UF cable, armored cable, or AC cable, and metallic conduit. NM cable is typically used for interior wiring in dry locations. UF cable is used for underground wiring and wiring in wet locations. AC cable is used for wiring in areas where physical protection is required. Metallic conduit is used for wiring in areas where both physical protection and grounding are required. The NEC provides detailed requirements for the use of different types of cables. It's important to understand the NEC requirements and to choose the right type of cable for the application. Finally, always remember to take the proper safety precautions when working with electricity. Electricity can be dangerous, so it's important to take precautions to protect yourself from electrical shock. Some common safety precautions include disconnecting power before working on electrical circuits, wearing rubber gloves and eye protection, using insulated tools, avoiding working in wet locations, and never touching bare wires. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the job.